Hello everyone, and welcome to today's webinar, The Problem with Kubernetes and Firewalls and How to Solve It. With your presenter today is Andy Wright, and he's with Tigera. But before I introduce things and hand things over to him, we have a few housekeeping items I'd like to cover about this presentation and the webinar platform in general. First off, today's webinar will be made available on demand after the live session is over, and will be accessible through the same link that you used to get to this webinar. It usually takes around 10 to 15 minutes for the webinar to be live. Copies of today's slides can be made available. You just have to email us at contact@tigera.io to request your copy. And most importantly, we'd love to hear from you from today's presentation. This is interactive. So if you have a question for anything our speaker is presenting on, please feel free to enter it into the questions tab of the BrightTalk interface, and we might take questions as they come if it's relevant, but we will also reserve a large amount of time at the end of the webinar for a full Q&A session. And so without further ado, I'm going to stop talking and just hand it over to today's speaker, Andy Wright. Andy?
Thanks, Michael. Just a quick introduction of myself. So I work on the marketing team for Project Calico and at Tigera. I have about 20 years of experience in enterprise IT, and that spans a variety of different positions, from being a software engineer to working with customers and as a pre-sales engineer, being a product manager, and eventually and currently becoming a marketer. So today what I'm going to talk about is firewalls. And the first thing that I want to do is give an overview of zone-based security architectures and firewalls, how they work, why they're in place, and the value that security teams get from them, because it's important to understand that context before I go any further through the presentation. So the first thing to go over is the network security architecture, and oftentimes this is called a zone-based security architecture. We find that some call it something different, but when you use this terminology, it's generally known by most. And a zone-based security architecture is the existing architecture that's typically implemented by security teams. So this is something which has been in place for a very, very long time. All of your applications and VMs are probably being managed this way if they touch the internet in any way, and I'll talk about that in a moment. So those are really for any publicly facing apps that are typically going to fit into this architecture. It's also the foundation for the security team's investments in their time and tools. Their processes are wrapped around this architecture, and that's really where their experience lies today and what's known. And you may need to deploy Kubernetes to this architecture, and especially if you're going to have workloads that to the public internet users via the public internet. So zones are essentially these sub-networks, and I'll walk through this diagram, but it starts with what we call the untrusted zone. This is the internet, right? There's a lot of bad things that are out there that might be trying to get in, and you have a firewall between the internet and any of your zones coming in. That firewall is commonly known as a perimeter firewall. So that's kind of the shell around everything that you're running inside of your data center that would try to attempt to keep the bad guys out. So then you have what's often called the DMZ, dematerialized zone, and this is where you have your internet-facing applications. So these are public servers or partner servers, and anything that an end user could connect to that is outside of your network. And we also have what we call a trusted zone, and so this is generally where your application workloads are running that shouldn't be accepting inbound connections from the internet, but they might be connected to via some of your internet-facing servers, and oftentimes then we have a restricted zone. This is your more sensitive workloads. That could be things like your databases or perhaps applications that can write to or read customer data. So sometimes we also see other types of zones in place as well. Management zone, where you might have some of your management servers and software, your backups that are running, and generally there's also some kind of an audit zone. So across these different zones, you may need to have some common place that you log information or generate alerts. So this is what we would call a zone-based architecture. I can walk through really how this is used. So the first thing is that applications will be profiled for risk. And so this is all about if this application is compromised in some way, what's the worst thing that could happen? And based on that, those applications will be placed into the proper zone. Then from there, between those zones, you use a firewall that you'll use. Oftentimes these are called an inline firewall. You have your perimeter firewall on the outside, your inline firewalls within the inside, and they'll monitor and control the flow of traffic. So visibility is important with this architecture, because the important thing that you're doing here is you're specifying which workloads can cross these zones, but then you want to monitor any traffic which is crossing the zone. And generally, that's where the firewall is going to be monitoring. Generally, within the zone, that traffic is trusted. So if you're within a DMZ and you're connecting to something else in the DMZ that's generally not being passed through a firewall, same thing with the trusted zone or any other zone. Oftentimes, there will be a need to monitor that traffic within a zone. This traffic is generally known as east-west traffic, whereas the traffic going in between zones and out to the internet is known as north-south traffic. So east-west traffic can use something called hairpinning, is what it's generally known as through the firewall, where all connections that are moving from one workload to another, some asset which is in the restricted zone, are all passed through the firewall. One of the challenges with this and why a lot of the other zones are left pretty open is that these firewalls are generally sized by the gigabits per second throughput, and this hairpinning then becomes very expensive in terms of both latency as well as the cost of your firewall, because high throughput firewalls can oftentimes cost in $1 million. So generally what you'll see is hairpinning would be done only for those high sensitivity workloads. So the zone architecture from the higher level, like what is this put in place for? The first thing is to protect the environment. So you establish boundaries, and then you control the communication between those boundaries or zones. So then what you want to do is detect any indicators of compromise, a connection which is attempted between zones, for example, that shouldn't be, or perhaps a connection that's occurring that looks a bit anomalous. And so this is where things like intrusion detection and intrusion protection systems come in. They're looking at the signatures of these different network flows and identifying things, malicious traffic, which is coming through. And then what you want to do is contain any type of breach or infection of the environment. So by splitting this into multiple zones, what you're able to do is have smaller pockets of applications, so that if you do have some advanced persistent threat, it has fewer workloads it could go infect. And so the other thing is that zones typically move in one direction. So you generally can't move from, for example, your restricted zone out to the public internet through the DMZ. Like, that would be bad, because that could be data being exfiltrated out of your databases. So generally they're going to move in one direction, so maybe if you can get in, you can't get out. Now, what I talked about with these firewalls and the zone-based architecture, it sounds very much like this legacy thing that might be running on-prem in your data center. but it's important to note that this is implemented in cloud-based architectures as well. So, for example, this AWS reference architecture that I found through a Google search for AWS reference architectures clearly show a DMZ as well as other back-end subnetworks that that are not connected to the public internet. Same thing for AWS. Azure has these types of zone-based architectures. You see a lot of this with GCP as well. So it's not all about on-prem. On-prem is certainly something that we see quite a bit, but it's also for these cloud-based architectures that it's put together. The overall benefit to the security team is that they're able to limit the exposure and the breadth of the impact. They're able to group their assets, and by grouping assets, what it means is they can actually prioritize their time. So if there's 1,000 workloads to look at, well, it's difficult to prioritize over which ones are really critical to keep your eye on, so they tend to spend more time in those high-risk areas. And that visibility provides you the ability to now detect suspicious activity which is happening. So anomaly detection in each one of those firewall zones. And then contain any advanced persistent threat to a single zone, so it can't really spread and infect the entire environment. So here's the thing, is that with that zone-based architecture, Kubernetes doesn't really jive very well with that. Kubernetes is generally a wide, open, flat network, and trying to segment it in this way is very, very challenging. And so I just walked through a little bit of the technical background on why. So Kubernetes itself will be running many, many different workloads, and those workloads are scheduled and they're deleted and rescheduled, they're scaled, and as that happens, you use IP address management to assign a new IP address to each one of these workloads. And so there's a certain CIDR block that's assigned to any Kubernetes cluster to enable that to happen. Now you can imagine that those workloads, they're reusing and recycling these IP addresses. So it's not really predictable up front what the workload identity is without, you use labels within Kubernetes, but you can't really use an IP address to do that, which is really where, some of the firewalls are focused. So if you have, for example, a workload that needs to cross through your inline firewall or from one zone to another, and let's say we have workload A, and it wants to communicate with workload B. What you end up having to do with the firewall is, since you can't specify just the single workload's IP address, what you end up having to do is open up an IP range. The IP range is generally going to match the same size of the CIDR block of that Kubernetes cluster. So by doing this, sometimes we call this theatrics. What you're actually enabling within this environment is every single workload from one zone to connect to every single workload on the other zone, and that just really gouges a giant hole in that zone-based architecture. And so if we look at Kubernetes workloads, and we try to split this within the zone-based architecture, the first thing is we're always going to have a perimeter firewall. And oftentimes we walk into environments and that's the only thing that they have is a perimeter, and the rest of the workloads can communicate with one another. But let's say that you do try to implement a zone-based architecture. The first thing is that you're going to have these large IP ranges, between each one of these firewalls. And this could be the case if you're using a single Kubernetes cluster, trying to carve it up, or whether you're using multiple clusters. And we've seen both in practice. The next challenge is that oftentimes some of these modern applications make use of third-party APIs, or they might be making use of cloud-native resources like Elasticache if you're running up an AWS or perhaps an RDS database. And you end up having to open up that large IP range outside of the firewall. And a great example here is if you have a security group and you've got RDS database sitting in that security group, you're generally going to have to let the entire Kubernetes cluster communicate with that RDS database. There is no fine-grained control. And there's also limited visibility here because you don't really see, at this point in time, any of the east-west traffic that's happening within Kubernetes itself. That visibility isn't really inherently there. Your firewalls that are in place have no visibility really because they're just allowing all traffic through. And they don't have a context for Kubernetes, meaning they don't know what a namespace is. Firewalls don't know what a pod's labels are. And so it's just letting everything through. And if you do have some type of a threat that hits your DMZ, that can have full lateral access to the entire environment. And so this is the challenge with the firewall, is that it's actually not able to implement that zone-based architecture. So there are a couple of ways to fix this, and we've done quite a few webinars on some of these topics, and we do around 100 meetups a year where we help folks understand how to implement this within their Kubernetes environments using Project Calico, our free open source software, and this can be done. So the first is network segmentation using network policy. If you're not using network policy within your cluster, by default the cluster is wide open. Everything can communicate with everything. But you can use network policy to create a DMZ, to create a trusted zone, a restricted zone. And these can be different namespaces. There are different ways to implement this. But at that point in time, you can control the flow of traffic. So you can use a default deny for any traffic which is going between these zones, and then specifically come in and whitelist any traffic that should be allowed. You've effectively implemented a zone-based architecture at this point. Also, if you need to have compute isolation, you're able to use a node selector for these workloads based on the zone to assign pods to specific nodes. So this is going to ensure that if you have a pod that's supposed to run within the DMZ zone, it's also only running on the DMZ servers. Now, this does achieve the network isolation, workload isolation, which was the goal of the zone-based architecture. But one of the challenges here is that this is a completely new model. So we're talking about network policies. We're not talking about firewall rules at this point. And this is just something very new to learn. The other challenge here is one of the things that we lose in this environment is that visibility into the traffic flows. So if something does flow from one zone to the next, we have visibility into which flows those are, and have some form of a log of that so that we can manage that and detect anything strange that shouldn't be happening. So you would say, okay, well, this is great. Like, we can fit inside of that architecture. The security team should learn this, right? One of the challenges that we hear, though, is that there's this rapid growth of containers. Everybody's running it. I think I see almost every single week that Gartner quote that, like, by 2020, 70% of organizations will be running containers. But what it doesn't say is how many containers they're going to be running and what how much Kubernetes clusters they're going to have. But if you go talk to some of these large companies, the security teams will say, yeah, that's like less than 1% of what I got to manage. And so, so that's the first thing. It's like, why would you kind of go learn something new and reinvent your model if it's just such a small percentage of what's happening here? And you'll get a lot of friction there. The other challenge here, and oftentimes we see this is why we see the perimeter firewall in place and nothing else put together, is that most security teams know about containers. right? And that's a workload. It can be assigned an IP address, and the container can be relatively static workload. And we see that oftentimes as the first step to moving to containers. But container orchestration is generally something that's very, very new. And we can stand out at Black Hat, for example, and talk to people coming up to our booth. And one of the first questions is, are you familiar with Kubernetes? And I always get a head shake. And it's just not very well known. So the concept of orchestration is very new to these teams, so they may not even know that it's a problem in many cases. So we do know that the teams are using the zone-based architecture. Kubernetes doesn't quite fit into it, and the security teams don't really have time or resources to learn these cloud-native concepts. Like, you're likely not going to get them to be developing YAML files for your Kubernetes workloads and segmenting them out in that way. They've got a lot going on with the other 99.7% of their environment. So this is a challenge that you can meet the current challenge to segment out your network and to implement the zone-based architecture, and you get that security, right? It's just not aligning with the security team's model. If you need to go that next step to align to the security team and the tools that they use, there's another approach that you can take. And so the goal here is to enable the security team to deploy Kubernetes to their zone-based architecture and get the same visibility, to get the same fine-grained access controls, and to use the tools that they're already using and know today. Like, this would be the vision and the easiest way to kind of work with that team in the early days of them adopting these cloud-native workloads. And so what I'm going to do today is a high-level demo of that being implemented through a firewall manager called Panorama, which is from Palo Alto Networks. And so I'm actually going to go ahead and launch my screen, and I'll bring you guys through what Panorama is here. So let me share my screen. Okay. Okay. So what I'm showing here is Panorama. And so what Panorama is a firewall manager. And generally, if you're going to have dozens or more firewalls that are running within your estate, you really don't want to log into each firewall to manage the firewall rules. You're going to want to have some centralized platform that manages all of your firewalls. That's what Palo Alto Panorama is. Now we have policies that are listed here. And these policies here are for different environments that we have. We have a DMZ, we have a restricted zone, and we have a trusted zone. And these policies, what we can see is, for example, DMZ source would show that anything that's coming from the DMZ, whether that's any address, user, or profile, and the destination is restricted or trusted, we should deny that traffic. And the same thing would go for the other zones. And so it's going to, by default, it will deny any traffic which is crossing those zones. Of course, my mouse moving in that direction doesn't work so well. For some of the others down here, like intrazone within the DMZ, restricted and trusted, will allow that traffic. So this is just a kind of a basic high-level setup of, of some firewall rules. This thing called device group, what this is a hierarchy. So these are the rules, and then I have several different, generally firewalls that would inherit those rules. And then you can add specific rules to each one of those firewalls. Now in this case, what I've done, and if I select, these are different Kubernetes clusters that we have. So if I select our AWS cluster, These are all in yellow because these are zones which have been inherited from the one above it. So just a quick overview of Panorama. What I'm going to do is I'm going to show you Tigera Secure. I'm not going to walk through a demo of this product, but what I'm going to use it for is our policy board. Our policy board is a more visual way to describe policies without me having to walk through YAML files on a command line. I'm going to try to stay off the command line except for one little command here today. And what we have here is a policy board, and this shows all the policies which are running inside of my Kubernetes environment. One of the things that's unique to our policy board is we have this concept of tiering, meaning any traffic must fully pass through all of these policies before they get evaluated by any of the other policies. And this is a way that we set up guardrails to enable a security team, for example, to create firewall rules and not have developers or applications like write a conflicting policy. So I'm going to launch only one command today, and it's just going to launch a Kubernetes deployment that we have. What that deployment is our firewall integration. So the way that that deployment works is it's going to sit, it will run in the background, and it will connect to Panorama. It will read the firewall rules, and then it will apply those into your Kubernetes environment as network policies. So it'll actually translate the firewall rules into Kubernetes network policies. And Tigera will pick up on any new policies that are added to the environment. So that might just take a second for this to run. But what we're going to want to see is that these DMZ, restricted, trusted firewall rules and how we're limiting access between these environments to appear up here as Kubernetes network policies. So we'll just give this another second to run. Not exactly a real-time sync. Okay. Here of network policies that have been created here, and this is our Panorama firewall tier of policies. And one of the things, the first thing you'll note is we seem to have fewer policies here. There's a whole truckload of them over here within Panorama, but we only have 3 that have been applied to the Kubernetes environment. And this is because of the power of network policies, and also what we're doing in the background is to have some intelligence to make sure that we're being efficient and we're not creating some policy sprawl. So the reason why I wanted to use the GUI today is it's much easier to look at a policy in a GUI like this. So this is our DMZ policy, and what I can see is that it denies any traffic that's coming ingress any protocol that's moving from zone equals DMZ. So this is basically enabling all of your zone-to-zone traffic. The same thing with your egress rules. So this says it's going to deny anything going out to restricted or trusted, but it's also going to allow anything within zone. So this is taking a whole bunch of different rules around the DMZ and where it can connect, and it's creating one single policy. Now, a couple different things that I can show here as well is, let's say that a new policy gets created in Panorama on my AWS cluster, and I can add some sort of a policy here. I will call this my demo policy. And let's say this is in the DMZ. And it's moving to our trusted zone. And I'll just grab some arbitrary service that's up here. And what I want to do here is allow that traffic. Okay, so I've created a new policy. It's going from the DMZ to the trusted zone. Now to commit the policy. So much like Tigera Secure, there is policy lifecycle management, so you can stage a policy before you're ready to commit it. And maybe perhaps I'll add even an additional one. Let's say that I add, let's see, a new zone up here called demo zone. Demo zone and commit that. So what should happen now is the process running in the back end will read these changes that have been committed to Panorama, and then it will translate those into the network policies. Now, the first one that I created is basically allowing access for one particular service. So that's going to go in and update one of our existing policies, our DMZ policy. I also created a new zone, and so in that case, what I should see is a policy for a new zone being created up here as well. And this can take just a moment for this sync to occur. Okay, so you see that there's a new demo zone that's been created. And this is for any zone called demo zone, and it's denying any protocol to the DMZ. So that was a very basic, quick zone that I created. It also would have updated here the egress to allow this particular service to communicate. And so in that way, your security team are able to control the zones, but you still have application teams who can deploy their application within the zones. But let's say that you have somebody who comes in through this interface and decides to add their own policy outside of the process of using Panorama, and I'm just going to call this a bad policy. I'm not really going to set any specific rules to it, but I'll go ahead and apply that. Now, this would be a bit of a problem because we're coming in and we're overriding the rules that have been set within Panorama, and now within Panorama, there's not really a visibility. Like, you don't really want to go register this as a new rule in Panorama. So there's some way that you have to mitigate this situation. And so what will happen with this service is that we'll actually go in and just go delete that bad policy automatically. We'll notice that it's not there. Now that action gets logged within the system. There's an audit log, but that's going to ensure that folks don't really go around the security team. And again, this thing takes about 30 seconds between each change to sync. Firewall rule changes don't really happen that often. In fact, typically when you ask for one, it it might take 3 or 4 weeks. So there you go. The policy has just automatically been removed. So I'm going to pause there. I just wanted to go over a high-level overview. There are additional things that we can do here in terms of monitoring the traffic flows. We can integrate this into the SIM tool, which is another tool that the security team will use to identify any anomalous traffic and indicators of compromise that they know to go in and investigate something that's happening within their environment. That's a bit outside of the scope of today's session. So I'm going to stop sharing here, and I will open this up for any questions.
Yeah, and while we're waiting for the questions to come in, I want to go ahead and talk about a few things. First off, I do want to mention something not listed here, 2 major great events that we have going on. One is we are doing a workshop series. So if you live in Seattle, Salt Lake City area, Minneapolis area, the Boston area, or Austin, we're coming with a full-day Kubernetes security workshop, which is hands-on with a hosted environment where you'll bring your laptop and be able to get hands-on experience in securing Kubernetes. And so that is on our website at tigera.io/events. The next one coming up is in the Seattle area, and that is coming next Wednesday, October 16th. And all of these are occurring in October. So, so go ahead and go there to see the list of cities and the dates. It's free, and it's great high-level technical training. So don't miss out on that. The other great event we're having is if you are coming to KubeCon, we are having a Day 0 event on November 18th, which is called CalicoCon, which is going to be all things Calico. It's going to be a full-day event, so that also is available from the website. If you go to events, actually on every page you will get a little pop-up that mentions CalicoCon, and you can go check that out. Also, as always, all of our on-demand webinars, we've been doing webinars now for well over a year, probably more like 14, 15 months now. 2 webinars a month, so all those webinars are up there for your benefit. And of course, all the other resources are available, including white papers, how-to guides, and so forth. The feature content, I would have a look at last webinar we did with Karthik Prabhakar, KP, our Senior Director of Solutions Architecture. He did a great, very, very hands-on technical webinar about troubleshooting Kubernetes connectivity issues. So those are the pieces of content. As we're waiting for some questions to come in, there is a little bit of a lag with the BrightTalk interface with questions. So we're still waiting. So Andy,
I'll take the first.
Okay, yeah.
I'll take the first couple here.
Yeah.
So the first question that I have up here is, can we compare the applications accessed through a gateway, which says I can't reach the services directly without valid credentials? Can that be equated to hiding them behind the firewall? So restricted and trusted zone access. And so, you know, in this case, if I'm understanding this correctly, it sounds like just restricting that access to a particular workload. The challenge is let's say you do have valid credentials to get into that workload. You know, from there, if you're not setting up some kind of a zone-based architecture, if you're not using network policy and doing segmentation, you know, someone could legitimately figure out how to access that service, and they would have, at that point in time, lateral movement and access throughout the rest of the cluster if it hasn't been segmented. And by default, that's generally how it's done. The cluster is left wide open. So I don't think that you can really equate, you know, credentialed access to a workload to using a zone-based architecture or firewall. And then another question up here is, one can monitor for security without deploying a firewall, which is true. And lots of vendors have sensors for this purpose that are not firewalls. And so it seems like we're conflating monitoring and restriction. And so that's absolutely true. And that's one of the things up front that, you know, that I was trying to say is that while I'm talking about this thing as firewalls, that there are many other constructs to create what we call the zone-based architecture. So you have things like security groups and network security groups and other ways that you can segment out an environment using VLANs and other tools. But effectively, it's the same outcomes that the security team is looking for. And so regardless of how that architecture is, Kubernetes does tend to have challenges in its out-of-the-box state fitting within those environments.
Okay. I had a question. Is anybody else doing what we're doing right now with this? With configuring firewalls and allowing the firewall manager to actually go in and update Kubernetes network security policies?
Not using a firewall manager, you can accomplish a lot of this just using Calico today, or Kubernetes Network Policy, to segment out your environment so you can reduce the blast radius, you can implement a zone-based architecture, and that's something which can be done through YAML files. Integrating with something like Firewall Manager is a relatively new concept. I haven't seen it been done anywhere else yet today.
Okay. Okay, well, it looks like we are out of time. So I'd like to thank you guys all for attending. Once again, please do check out the events section of our website to check out the great workshops and CalicoCon coming up at KubeCon. So without further ado, Andy, thank you for presenting. Thank you everyone for attending, and we will see you next time. Thank you.